Whoa. My eyes are up here, buddy. Let's just take it slow. Hey, I'm Ryan. Welcome to part 6 of the Advent of Code series, where we solve Advent of Code problems with Elmlang. So, the last video we ended, it was day 5. Day 5, we have 10 stars total. Each day is worth 2 stars. And we're still on track here. So, it is December 6th. I am doing day 6. I haven't looked at any of these problems ahead of time, but we're going to solve them together in the browser using Ellie, which is going to allow us to write some Elm code. And then, let's see how it goes. Let's dive into it. So day 6, lanternfish. The sea floor is getting steeper. Maybe the sleigh keys got carried this way. So we're a bunch of elves looking for keys in the bottom of the ocean. Just some context for you. A massive school of glowing lanternfish swims past. They must spawn quickly to reach such large numbers. Maybe exponentially quickly? You should model their growth rate to be sure. Sounds fun. All right. You know nothing about this specific species of lanternfish. Although you know nothing, you make some guesses about their attributes. Surely each lanternfish creates a new lanternfish once every 7 days. However, this process isn't necessarily synchronized between every lanternfish. One lanternfish might have 2 days left until it creates another, while another might have 4. So you can model each fish as a single number that represents the number of days until it creates a new lanternfish. Furthermore, you reason, a new lanternfish would surely need slightly longer before it's capable of producing more lanternfish, 2 more days for its first cycle. So suppose you have a lanternfish with an internal timer value of 3. After 1 day, it's 2, another day it's 1, another day it's 0. After another day, their internal timer would reset to 6, and it would create a new lanternfish with an internal timer of 8. After another day, the first lanternfish would have an internal timer of 5, okay? And then the second one would have an internal timer of 7. A lanternfish that creates a new fish resets its timer to 6, not 7, because 0 is included as a valid timer value. Okay. The new lanternfish starts with an internal timer of 8 and does not start counting down until the next day. Okay, realizing what you're trying to do, the submarine automatically produces a list of the ages of several hundred nearby lanternfish. For example, suppose you were given the following list. So we'd start with 34312. These would all get decremented, and then since this one was at 0, this one would go reset to 6, and then give birth to a new fish. Okay, so we do that. Each day 0 becomes a 6. And adds a new 8 to the end of the list. While each other number decreases by 1 if it was present at the start of the day. In this example, while each other number decreased by 1 if it was present at the start of the day. In this example, after 18 days, there are a total of 26 fish. After 80 days, there would be a total of 5934. How many lanternfish would there be after 80 days? Okay, so how we're going to start this is we're going to have our initial state here, and we're just going to paste it here. And all I've done to print this out is our main function here is just printing out the existing input, and it's using string.trim to get rid of this like starting and ending white space. So in the previous videos, we've used that function for that reason. So this is going to be our initial kind of group of fish. If we called string.split on that, on the comma, we'd get a list of strings. And then in order to turn those to numbers, we're going to use filter map, which we saw in a previous video, which allows us we can combine that with string.toInt to basically convert 34312 into a list of numbers. So we took that raw input, and pretty quickly we were able to get a list of initial fish. So this is going to be like the initial fish value. I'm going to move that into its own function. Initial fish. Cool. So again, initial fish is just going to be a list of integers. So I'm going to copy this. Sorry, moving things around. So that's how we're going to get initial fish. We'll take the input and we'll trim it there. So this should still give us the same result. Okay, so the next step is we're going to need to have like a simulate function. So I'm going to have just a single step where it just simulates like once. So what simulation is going to look like is it's going to take a list of numbers and return a list of numbers. So as we saw in this example, we're basically going to go from this to this. So all we're going to do for that is we're going to call this list the fish, and if we want, we can even give this a type alias so we can talk about it more clearly in English as we go through things. So an element type alias is just a nickname for another type. So instead of us typing list of int everywhere, we can type list of fish, and that'll make it a little bit easier to read the code. Sorry, I kept typing the wrong line there. So if there'd be no changes, fishies. I'm gonna make that plural there. So if there's no changes, basically we just return things as they are. But what we're gonna want to do actually is like kind of like step through. And so what happens to each fish each time we go through? So what we can do is we can say we can make a function which is like handle fish. What's a good word for this? Handle fish. I guess aging. I don't know, weird name. But what handle fish aging is going to do is it's going to take in a fish, and it's either going to return the updated fish, so like a lower number, or it's going to return 2 fish, right, if it gives birth. So what we're going to do is we're going to say, for now I'm just going to represent this as a list of fish. So each fish, based on their number, so I can say if the fish is at age 0, then we're going to make it give birth. So we're going to set a thing to 6, and then basically set the new fish to 8. Else we're going to return that fish number -1. And that's kind of like how the aging process works, right? So if I compile this, this is returning a list of lists. So we can either call list.concat, which will flatten the lists. And this is our next step, right? This is what we saw in the output. So 23201, that represents this after day 1. So we can call concat like this, or we can use the function that we learned about from the Elm docs site here. There is a concat map function, which basically calls map and concat for us. So we're going to use concat map instead. And basically this code is the same as this code. So this will give us the same answer. Cool. So that's pretty straightforward so far. So we're going to simulate, and basically we want to call simulate as many times as we want, like days. So if we wanted to simulate 2 days, we call simulate twice. And then here you see that the fish is being born. We wanted to call it again. You'll see another fish was born. And then this day, 2 fish are going to be born because these zeros are going to age. So rather than copy paste this 80 times, we're going to say simulate like how many times? Simulate for multiple days. And we're just going to say 80. So simulate for days. Simulate for days is going to take an integer. It's going to take a list of fish, and it's going to return a list of fish. So it's basically going to call that function over and over and over again. So we're going to have like some days remaining here. And what we're going to do, these are going to be the fish. We're going to say if days remaining equals 0, then we're going to return the fish as they are, fishes. This is a list of fish. Else, we are going to simulate with days remaining -1. So we're going to subtract the days remaining, and we're going to call the simulate function on our fish. And remember, simulate will return a new list of fish. So it's basically going to update our loop each time we come through. So if I do that, let's just verify it works for 1. Oops, simulate, this is gonna be fishes. Fishies. I should have named it fishies, that would have been cute. So when we do that, we can say 1, and we can also say 5. And this is gonna get us the same number that hopefully we see. Well, I guess the order's jumbled here, but I think this is the same number after 5 days. We have 1, 2, 3, 4, 5. So we have 9 total fish after 5 days. And that's what we, oh, we actually have 10 here. Maybe I'm doing something wrong. 5, 6, 5, 3, 4, 5, 6, 7, 7, 8. Let me just make sure that I'm doing this correctly. So I said simulate for 1 day. So that got me 23201. It's 23201. And then when I did for 2 days, it's 121 and then 608. 21608. Here they're appending to the end. We're kind of appending next to the fish because that's how our cat's working. But it doesn't really matter. It's 0812108. So if I do 3, 0, 1, 2, 2. Maybe I just miscounted the fish. Yep, you know what? I totally just miscounted. There was 10 there the whole time. So I think we were okay. Let's just, easier way to test this is to just simulate for 80 days. That'll give us our list, and then we just see how many fish we have. That's 5934. Is that what the puzzle was saying? Yep. Okay. So this works for the test input. Since I have a admin of code, I logged in with an account. I'm going to get my own puzzle input here. And what we do with this is we copy this. I'm going to save this answer. And I'll include the links to these code snippets in the description below, so you can play around with the code. But I'm going to paste in my puzzle input. And I get 360,761 for my answer. So let's see if that's right. Woohoo! Okay, cool. We have 11 stars. 1 more to go for day 6 here to get to 12. And so for part 2, they're just going to make a little twist on the problem, and there's going to add like another layer to it to see how we do. But before I forget, I'm going to copy this, and I am going to move this over here. This is where I keep my notes. Day 6, and this is going to be part 1. And then I'll leave a little slot here for part 2. Okay, so I've kept track of that. Compiling this gets us back to 5934. And now let's get started with part 2. So what we're going to do is click this button and see what's new. So it says, suppose the lanternfish live forever and have unlimited food and space. Would they take over the entire ocean? After 256 days in the example above, there would be a total of the big number. There would be a total of 269,844,57539 lanternfish. How many lanternfish would there be after 256 days? Okay. So I think what this is doing is this is putting our data structures to the test. I chose a list because it was easy to use, but maybe we're going to run into problems if we try to simulate for more than 80 days. So if I do this, let's see if we can even run that. So the problem with this is for each time we're creating a new fish, we are inserting to a list. What we could do, so see how slow this is. So what we're going to want to do is, I'm going to actually exit the page, refresh here. What we're going to want to do is instead of storing each of these fish in memory as a list that keeps growing, just as a reminder that this list is that's how long it is. It's 5,000 long. And the last problem was 360 elements long. So we're not going to be able to use a list to keep track of the fish anymore. So what we're going to do is instead of using a list, let's comment this out for a second. We're going to keep track of the ages of fish. And then we're just going to kind of count how many fish we have. So as we go, that's what we're going to be storing. So let me compile this. Okay, so starting with 34312, instead of having a list of fish as our answer, what we're going to do is we are going to create a dictionary that stores a number and then tells you how many of those fish there are. So for example, this would be a dictionary where we'd have one fish that's 1 year old, we'd have one fish that's 2 years old, we'd have two fish that are 3 years old, and one fish that's 4 years old. And we're not going to like keep growing a list. We're basically going to just increment a number in place. So I think that'll help. So this will be a function called toFishCount. And what toFishCount is going to do is it's going to have a dictionary, which is going to map the age of a fish to how many we found. Again, we're going to use type aliases here to make it clear what each of these integers are. So to kind of quickly show you why I'm making these type aliases, this is the signature to our function. If we didn't use these nicknames, we'd have a dict of int to int, and it's going to be kind of hard to remember which is which, and we might accidentally jumble them up. Elm has even more powerful ways to like prevent you from mixing up integers, but for this video, we're not going to use them. We're just going to focus on making this a little easier to follow. So what we want to do is, given a list of fish, we're going to want to go to a dictionary. So this is going to be our fish list. We call it a fish list. I don't like fishes anymore. I think it looks weird. And I think a lot of these places are going to, a lot of this code's going to get modified to use a dictionary now. So what we're going to do is, instead of returning a list with a map, we're going to use fold_L. And how fold_L works is we're going to have a fish. Each fish in our list is going to come through. We're going to have the dictionary that we're updating, and we're going to return basically the modified version as we go. So as we're building up these counts, initially the dictionary is going to be empty, and then we're going to have our list of fish, and basically each fish, 34312, is going to make us update this dictionary. So we're going to call dict.update. Dict.update has kind of a similar style to fold, where there's going to be 3 arguments, but we're going to update at that fish age. I'm going to call this fish ages, because I think that'll be easier to understand. Fish ages, this is going to be a fish age. So at the given fish age, what we're going to do is we're going to basically, we're going to insert, we're going to count track fish age. This is a function we're going to write together in a second. And what this function is going to do is it's going to take the count that might already exist for that age. So if it's the first time we're in here and we see number 3, we're going through this list, we're going to see number 3, and we try to get the count that we have in our dictionary at number 3, it's going to return like nothing. So we're going to want to initialize it, stuff like this. In the last video, we did something very similar too. So this should feel familiar if you watched day 5. So case maybe count. So the case where this is the first time we've seen that age, we're going to insert 1. And then if we have an existing count, we're going to return, sorry, I'm going to put this, wrap this in adjust, because it's maybe we're returning. We're basically going to increment what we found. So I'm going to format this, and when I compile this, hopefully we have a dictionary with 4 keys in it, and 3 of those should have a count of 1, and the one with 3 in it should be 2. And we also are going to need to import dictionary from the top. It's included in the core Elm library, but you do need to import it. Okay, initial fish is a bad name. So initial fish is not that anymore. Cool. So what we're seeing is we have these entries here. And then let's simulate it. Let's update our simulate function to basically see how our dictionary is going to change from day to day. So our simulate used to take a list of fish and a list of fish, but now it's going to take this fish. Yeah, I'm going to call it a fish dictionary, or a fish dict. This is another alias. And basically, instead of taking a list of fish and a list of fish, it's going to take a dictionary and return the new dictionary. So again, this isn't going to use concat_map. What this is going to use is another dict.update. So dict.update is going to take our fish dictionary, and we're going to have, we're basically going to dict.update. What we're going to do when we simulate is we're going to kind of like step through all these things. Maybe a dictionary.map is really what we want. Let's take a look at the core library. Dictionary.map. So map's no good. I think fold L is what we're going to want. So fold L we're going to use on our dictionary. So it's going to look just like a list.foldL. Let's see. Let me collapse this. Yeah, let me see. So a fold L in a dictionary is just like our fold L here, except we're also going to get like the key and the value instead of just the key. So the key for our dictionary, our fish dict, it stores an age for the key, and it stores a count for the value. So this is going to be the count, and this is going to be the age of the fish. I'm just going to call this age in our code to make it a little bit easier to read. And then what we're going to do is we're going to build up a new dictionary based on what we're seeing. And hopefully that will lead to kind of like a better system here. So what we want to do is each time we go through an item in our fish dictionary, we have an age and a count. We're going to want to simulate for that fish, for that age, and for that for that age, how many we want to have. So I'm going to start by saying, do we care about the counts? I don't know if we care about the counts for this. Oh, we do care about the counts because, let's take a look at 3, for example. So if there are 2 fish that are 3, we're going to want, if there's 2 fish that are age 3, they're both going to go down to 2. So we're going to insert something at a lower age. So what I'm going to do is say if age is 0, so this is going to be the thing where they give birth, right? So this is going to be, so for however many fish we have, so let's say list.range. So if we only have 1 fish, this is going to be a list where the value is just 1. I kind of want to break this out into its own function because it's starting to get hard to talk about. So this is going to be handle fish age. Yeah, this will be handle fish aging again. And we're going to change the implementation of handle fish aging. I'm also going to update this. This function is going to stay the same, except it's going to be a dictionary that we're passing around instead of a list. So yeah, so this is going to be a fish dictionary and a fish dictionary. So this function's fine. It's just the type's changing, but we're always returning the same thing, so it works out. But handle fish aging is going to be a little bit different. So previously we were returning lists of fish, but now what we want to do is we're going to want to take the age, how many fish we have, and then we're going to take a fish dictionary and return a new fish dictionary. So this is the age, how many fish we have, and then the dictionary here. So what this is going to do is if the age is 0, we're just going to call a function. We'll kind of put this over here in a separate function. So the age is 0, give birth to fish, and we'll say how many fish need to give birth, because that'll tell us how many 8s and 6s we want to insert into the dictionary. And then we're going to give it the current state of the dictionary. So we'll write that function in a second. And then if the age isn't 0, we'll say decrement fish age for that many fish. And then we'll give it a dictionary so it can insert however many it needs to. So all we have to do now is just update these 2 functions. So we have our count, we have our fish dictionary, and what we need to do is return a new fish dictionary. So if I give birth to, I'm sorry, let me do that. So if I give birth to 10 fish, not me personally, I've never done that. I don't think that's a good idea. If I give birth to 10 fish, what we want to do is basically create 10 8-year-old fish and 10 6-year-old fish, or 6-day-old and 8-day-old fish. So the way we can do that is we can make a list. This is going to give me a list. We're going to use list.range, which we saw in a previous video. Maybe it was day 4, maybe it was day 5. But basically what that's going to do is this is going to allow us to say like 1 through 5, and that'll give us a list 1, 2, 3, 4, 5. And what we want to do, we want to do here is for each item in the list, we're going to basically have like a number, doesn't matter. We're going to ignore that. But we're going to have our dictionary, and we're going to return like an updated dictionary. So our initial state is going to be the fish dictionary that got passed in. But what we're going to do here is, and I'm going to move this into add fish to dictionary. Add fish to dictionary. Is going to take a number, that's the how many fish we have, we can ignore that. It's going to take a fish dictionary and return a fish dictionary. Add fish to dictionary. So we can ignore the first input, and we're just going to have these dictionaries. And what we want to do is we're going to want to dict.insert6 to that dictionary. And we're going to do dict.insert8 to that dictionary. So each time a fish gives birth, it basically inserts a 6 and an 8. And so actually by doing this, the dictionary is not going to help with that. I kind of wish we had a different data structure that just kept track of counts. That would have been a nice one to make. What we want to do is we're going to want to add to fish dict 6 and add to fish dict 8. So that's going to be one last function we write where all of them seem to have this this signature for some reason. And so what this is going to do is it's going to be a new age. This is going to be a fish dictionary. And what we want to do is exactly what we did here. We're going to want to, oh look, that's the function that we wanted to write in the first place. So this is already here. We already wrote that. So this is add fish to dict. And notice how these have the same exact variables, right? So like the fish, age, and the dictionary. Just go here. Woohoo, we already wrote it. Okay. So for give birth to fish, that's correct, I think. But we still need to implement decrement fish age. So decrement fish age is going to be a really similar situation. And it's going to take a count, and it's going to return a fish dict. But what decrement's going to do differently is for all of these fish, it's just going to kind of create like this list that we saw before. I'm going to copy all that verbatim because it's all the same so far. But what we're going to do is we're going to do the age -1. So this is going to be like the new age. This is what we're going to pass in. So actually here, we should pass in the new age that we want to do, because otherwise we won't know what the fish's ages are. So new age is going to go here. I think that's right. Add fish to dict. Oh, add to fish dict. That's not what I want. It's add fish to dict. Boop, 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 boop. Okie dokie. So what we're seeing here is after 1 day of simulation, we're going to have 2 fish of age 2. After another day of simulation, we're going to have 2 fish of age 1. And then if we do this again, we should see that the 1 is now 0, and then this will give birth to 2 fish. So this time we should see 2 fish with 8. And yep, so there we go. So instead of doing this by hand, let's see if it's fast enough for us to simulate for 80 days. And that was a lot faster. So that one didn't crash on us, right? And that's because we're not building a crazy big list. So now all we need to do is get the values of this dictionary, because that's how many fish we have of each age. And then all we have to do at the end is just call list.sum, which takes in a list of numbers and adds them together. So 5934 is what we get after 80 days. So let's see if 256 crashes. Don't crash, don't crash, don't crash, don't crash, don't crash. Don't crash. Oh no. There's definitely a more efficient way to do this. And once we kind of saw it happening, I kind of realized what it was. So, okay, we might have lost our code. Let's, hopefully we didn't lose everything. We might have. Dang it. Oh, man. Oh, recover. Okay, great. Great, great, great. Okay, we're not going to run this again. Okay, so 5934. Okay. Thank you, Ellie. All right, I'm going to save our progress here real quick, just in case anything crazy happens, because I think this is a good checkpoint. But what I was noticing while we were doing the simulation was that we really don't need to create a new dictionary every time. We just needed to update the keys as we went. It was a lot simpler than the kind of like by hand stuff we were doing. So let me show you what I mean by that. So before we did the dictionary values, we started with a dictionary. Just focus on these numbers. We have 1, 1, 2, 1, right? If I simulate for a day, we had 1, 1, 2, 1. What's happening is each day, all the keys are decrementing by 1. So we still have 1, 1, 2, 1. And the only time where the keys will like change in position is when a fish is born. So really, if I just say if the age, we can just map through this dictionary and say, hey, if the key is 0, then I want you to basically like add a 6 and add an 8 add a 6 and add an 8 to our list. If not, then just deal with the counts. And I wonder if we even needed a dictionary for any of this. I think we do. I think dictionary is still a good choice. Okay, so what we're going to do is we're not going to do dictionary updates the way that we did. So 2 fish count is still okay in my book, but I think the simulate function is going to change. So instead of doing this with our dictionary, what I want to do is I want to I still want to do a fold L, but let's modify this behavior. So instead of doing this, which is like adding fish to the dictionary, what I think we want to do, and I'm just going to do it all in line here, is we are going to insert. So give birth to fish is hard, but this one's easy. So we'll just say dict add fish to dict, track fish age. Number to add. Okay. Okay, track fish age. So what I want to do is, let's go back to, yeah, so kind of back to like the first step. You can kind of see how all these numbers are like just decrementing. What we're seeing is like for the counts, they're all just shifting over. So I think the idea here is going to be, this isn't going to compile because I messed stuff up. But we can look at the compile errors and see. I'm gonna call this that for now. And then this track fish age is always going to have 1 for now. So let me just, this is what we had before. So when I simulate 0 days, simulate for days, 0. So when there's no changes, it's 1, 2, 3, 4. And then when we do 1 day, it kind of shifts over to 0, 1, 2, 3. 0, 1, 2, 3. These are all the keys. So that always happens if there's no fish that are giving birth, right? So what we can do is we can handle fish aging. This will be like a to-do. But what we can do for this is we can really just slide stuff over. So if we're going left to right, yeah, we're gonna basically do dict insert, then age -1, that count. I think that's really it. We're just gonna insert that value there. I don't know if insert's a good choice. I'm afraid insert's gonna overwrite the fish that have given birth. Sorry, I'm kind of getting confusing on this last one. I thought my performance fix would work, but actually I'm still doing a lot of work. I almost want to scrap. I almost want to scrap this just so we can kind of think about it at a higher level. So I think 2 fish dict, or yeah, 2 fish count was the right idea. But what I want to do is I want to keep this guy around. I think simulate's fine. Simulate for days is definitely good. But for the handle fish aging, I kind of want to like not. So I'm gonna just delete this code. We still have add fish to dictionary. And what we need to implement, oops, yeah, and I renamed this to fish count because it's kind of hard to say. Fish count, fish count, fish count, fish count, fish count. So handle fish aging is the thing. So now we need to take a look at this and see how we're going to want to simulate a dictionary here. So if I have a dictionary, and the values, if I do dict.map, so how dictionary.map works is I can do KAB. So this is the key, this is the value going in, this is the value going out. So we can actually return a list here if we want. Or return a custom type, which might be nice. And then we can condense that. So what I'm going to do is I'm going to say to fish action. So we're going to do something a little bit different this time around. We're going to make a function called to fish action. And it's going to take a single fish age. It's going to take how many fish there are, and it's going to return a fish action. And we'll talk about what a fish action is in a little bit. But basically, this is going to be like, do they give birth, or do they basically age? And this will store get older, I guess is a good name. And then we'll take the age and the count and just kind of store that to fish action. So age count. So if the age is 0, then what we're going to do is return give birth. Else we are going to get older. And what get older is going to do, I'm going to get rid of that type signature for now. What get older is going to do is it's going to take in the new age, which is going to be age minus 1, and it's going to take in the count. So how many of those fish did that? Cool. So if I do this, and this is going to be a dictionary of age to a fish action. Just gonna forget that I ever had a type erase there. And we're gonna forget that this existed for a second. So, and I don't think we do add fish to dict anymore. Okay. We totally did. I was wrong. All right, so instead of simulate for days 1, we're just gonna say simulate once. So what we're seeing is that all these fish are getting older. And maybe I don't even need to keep track of the age in the count. Or I guess I probably do have to get rid of the count. Yeah, okay, I'll do that. So what dict.map is going to do is it's going to give us this. It's dictionary. And then what we want to do is we want to like get the values out. This is going to be the actions. Oops. I'm going to get rid of these annotations because they're not right until I'm done. So get older, get older, get older, get older. If I ran this again, I can't call it again because I haven't put it back into the dictionary form. I can't call it on the result, but let's just let's keep going. So get older, get older, get older. This is going to be a way to basically go to a to create a fish count. So each of these actions track fish age, simulate. Get to really see me struggle for this one. From fish actions. So this is going to take a list of actions. It's going to give me back a dictionary, basically, of age to count. That's the fish count dictionary. So list.foldL is going to go through all the actions that we want to do. Again, I almost want to scrap all this. I'm trying to think of the simplest way to do this, and I feel like each layer I add is making it like a little bit weirder and harder to follow. But let's push ahead and see if we can get this to work. We're gonna have like 6 different solutions for this, and they're all gonna be too slow, is what I'm afraid of. This whole like updating dictionaries is what's concerning to me. So this is gonna take a dictionary one at a time, and it's gonna take an action. Dictionary, and what we're gonna do is say, in the case for the action, is give birth. I don't see how this is any different than the last solution I had. Just needs to keep track of how many fish are giving birth also. Yeah. So that we'll say dict.insert. This might be faster because we don't have to do any looping for an insertion. I think this would be faster. So we're going to create 6 fish for how many we had. So we're going to insert 6 that many times. What I don't like about this is that it's adding It's going to overwrite, insert overwrites. Really what we want to do is update at 6. And what we want to do is that increment thing, the track fish age. Yeah, we want to call track fish age here. So update's going to do the whole like, hey, like if it's the first time we see it, do that. If not, we're going to like add it. I think this will be more efficient. Track fish age, and then we're going to give it the count of how many we want to insert. Okay, I do think this is going to be better. It might not be good enough, but hopefully it won't crash on us. Get older, and then this is going to be the age and the count. Basically, we'll do the same thing here. But we will insert that. So I think this is correct. Okay, so from fish actions. So that's one step. I think now that it's returning a dictionary, we can call it again. Okay, so we are doing that. And then simulate. I'm just going to add that type annotation back in. And we're going to do that again. So simulate for days. Oh, sorry. Values. Oops, 80 days. Oh, list.sum. Okay, so that is it. So that's the number we had before. Oof, I almost want to say this is a different thing. So I do have this copied in the clipboard. I'm going to save this other solution. We're going to have all of our variants here, all of our attempts. This is going to be like part 2B. And that last one where we did the dictionary thing is going to be part 2A. Okay, so we're basically keeping track of all these as we go. So all these should be available in the video. Let's try 100. Seems like it's going pretty quick. Okay, I feel better. Oh, great. That was so fast, so snappy. Okay, and it's because we're not creating these lists of numbers and then looping over them. I think that's really where the savings came in. So as we compare 2A and 2B, hopefully we'll see a better thing. I'm gonna save this. And fingers crossed we're done, because I can't embarrass myself anymore. I don't want to do it. I don't like it. But that's okay. For these puzzles, I knew there was going to kind of hit a wall where I started getting more and more confused, and you just had to watch me like stress through it. Wow, okay, that was so fast. So we're getting a number that's how many millions is it billions? 1 trillion. That's a lot of things. Hooray! We did it. Okay, I'm very happy that problem's over. So just to recap, basically what we were left with at the end was, instead of having some crazy list of like, look how long the list would have to be. This is each type of fish, right? Our list would have run out of space so fast that our heads would spin, right? So with this, we're really just keeping track of the counts, and the way we're inserting is we're using. You can hear in my voice, I'm so excited all of a sudden. I'm gonna add the type annotations back in. So I think that's still right. Cool. Okay, so basically when we're simulating, what we're doing is we're mapping through all the numbers we have. Instead of like creating a whole new dictionary or a whole new list, we're just kind of looping through and updating all the integers. These actions really did help make this logic, at least for me, it was a lot easier to follow like what we do in each of the cases. And then from fish action was actually pretty easy to read too. So I'm kind of surprised that the action pattern is kind of like using a custom type here. In Elm, this is a custom type. It's kind of like an enum that can hold on to values. But using a custom type here actually really helped me be less afraid of the code. So what I'm going to do is I'm going to quickly go back to this and copy the test input wherever it is. Oh, there it is. put it back in here, and then save this again now that I have the type annotation back in here. And so all we did here was we got the values, and those are just a list of numbers, and then Elm's pretty good about being able to just sum those up for us. So that's how we got this. So I'm going to save this. Thank you so much for watching. I hope to see you in a future video, day 7. You can check out the links in the video below. It's going to have all the solutions that we have, as well as a link to the playlist in case this is the first video that you're showing up to. And yeah, there's a link to the Elm Slack. If you enjoy these videos, leave a comment. If you're confused about anything, like ask a question. And then I have a link to the Elm Slack in the description. You can say, hey, my name is just @Ryan. And yeah, thanks so much for watching. I'm going to call it there, and have a good one.